I use the word tinkering loosely because some of these came together in a couple of hours. And I think that's either impressive or probably mildly alarming, depending on your relationship with traditional development timelines. So the next few minutes are about what happens when you take Norsk's native API architecture and point a large language model at it. Specifically, I've been using Norsk with Cursor, Claude, and Gemini, though the principle applies to whatever AI you happen to be arguing with this week. So let me show you what that looks like in practice. So we start with a fairly standard Norsk vision switcher. Adrian just introduced you to the concept of Norsk. A multi-view of 4 cameras. I'm running 3 in the demo. There's a source switch component running. We've got Singular Live for browser-based overlays coming in and some on-screen titling. And I'm doing a single run fixed ladder encode since this is running on a relatively old dev server in my office. So nothing too exotic, nothing you wouldn't recognize as a sort of as a workflow that you might want to run in Norsk. Of course, every Norsk workflow generates its own specific API automatically. So every input, every component, every output, all of it's fully introspectable, fully controllable. It's one of those things that sounds like it should be obvious, but it isn't. You know, it's not an intuitive thing to find in most products, and this is, I think, a great feature of Norsk. So here's a bit that's worth paying attention to. Every Norsk workflow generates its own specific API. Every input, every component, and so we took that API and fed it into, in this case, Claude, and within a couple of hours, we had a functional dashboard, a working vision mixer running in the cloud, built by the AI and controlled through the web page, just using those same API calls. So no bespoke middleware, just the system as it stands. And what does that dashboard look like in practice? You know, 4 channels. Click a source, you're on that camera. Control your graphics, manage overlays, all from a browser, all from anywhere. You know, a couple of hours to build that using an AI. Awesome. That got me hooked at the beginning of the year. So we started playing with some MCR and control room features, and you know, Norsk deeply exposes what's happening inside a workflow. Every component logs relevant state, every transition, every signal, every overlay. It's all structured data, and it's all available in real time. And that gives the AI model something to actually work with. It's rich, meaningful, well-organized information, not the kind of opaque black box stuff you might have historically had to deal with. So in this MCR-focused example, I use that to build a control room dashboard that lets you operate the system, turning graphics on, turning the overlays on and off, and I was seeing how that was affecting the encoder delays and so on. So you can chart and represent what you need in the control room, and the control room's no longer guessing. But take that an extra step, and it becomes interesting for people running real-world broadcast operations, because in a master control room environment, you can't watch every feed simultaneously. You manage by exception. Something goes wrong, you need to know quickly, and ideally without someone having to stare at a monitor bank for 6 hours. What we demonstrated was AI monitoring a video feed and identifying content. The workflow switches between some fencing footage and some drone flying footage. Gemini is watching the output in this case and correctly identifies which is on screen at any given moment. So you can see the monitor bar at the bottom. The practical application is straightforward. You're expecting fencing coverage, you get drone footage instead. That's a fault condition. The AI flags it. It's red, it's immediate, it's unmistakable. But when the content returns, the alert clears within a few seconds. No manual acknowledgement, no lingering false positive. Model adapts because it's understanding what it's seeing, not just matching against a static rule. For an operator managing dozens of feeds, that's really genuinely useful. It's not revolutionary, it's just useful. Built in hours, and it's on top of infrastructure that was already there. So then we wanted to explore making that actually monetizable and something practically valuable. So here's we use Gemini to make real-time decisions about when to play an advert, not time code triggered, not rule-based, actually watching the content and making a judgment call. The workflow had 2 sources, some live fencing footage and an ad loop from a file. Gemini monitored the live feed, and when about ended, a natural break in play. The model identified that as an appropriate moment for the ad break and acted on it autonomously. It ran the ad, then when it judged the time was right, I'll just fast forward through it a little bit here because the ad break went on for the duration of the break. But as they came back to the piece, it judged the time was right and it returned to life. So I'll be honest, it's a proof concept. I wouldn't put this in production tomorrow without a lot more testing, a lot more thought about the edge cases. But the point it makes is it's real. You're no longer entirely dependent on a producer hitting a button at precisely the right moment. The AI is watching, it's understanding content, and within the boundaries you define, it can act. And that's a meaningful shift in how live production workflows can be structured.